point of time, we need to identify what is Ohm's law. So if I have a particular conductor with its physical characteristics being constant, what I mean by that the temperature of the resistor should not change, the length of the resistor should not change, or the area of the resistor should not change. In case you're wondering, sir, how can a length or area be changed? So if you might remember in our chapter of deformation, we said that if we apply stress, then there would be a change in length and area of cross section. So guys, the thing is that if no stress is being applied, the temperature doesn't change, then according to Ohm's law, means, I mean, if you keep the physical characteristics of the conductor constant, then the voltage across the conductor is directly proportional to the current flowing through it, which means if there's no voltage, there's zero current. If you have a particular voltage and current, and if you double the voltage, the current would also get doubled, and so on and so forth. So that's what, guys, Ohm's law is. Ohm's law says that for no change in physical characteristics of the conductor, the voltage and the current are directly proportional to each other. And it simplifies as V is equal to IR. So, and you can demonstrate that experimentally as well. That is, you can take a conductor and you could connect a voltmeter across it. You could connect an ammeter in series with it, and then you have a variable power supply. So if you keep on changing the voltage and of the EMF of the power supply, and keep on measuring the voltage at the current readings, and you take different readings and plot a graph, then you'll see it's a straight line. So every time you end up seeing a straight line, so that means it is obeying Ohm's law. If it is obeying Ohm's law, so that means the voltage and the current are directly proportional to each other. In situations where the conductor is not going to be obeying Ohm's law, then you would see that the graph is not going to be straight line. So it's going to be a curve. And there's also one more thing that you should remember. That's something I've written down in purple over here, that an increasing resistance means the graph would bend towards the voltage axis. So that's like one way. I will explain that to you as well, but somehow if you see the graph bending towards the V axis, then it will be increasing resistance. If you see it bending away from the V axis, that is towards the I axis, so that would be decreasing resistance. So ohmic conductor or a fixed resistance is the one which obeys Ohm's law, and the graph is going to be a straight line. Whereas if you don't get a straight line, then you would know that that particular conductor is not obeying Ohm's law. But despite the fact that the conductor is not obeying Ohm's law, you would still be able to determine its resistance by the ratio of voltage and current. So if you have a particular point on the graph, and if you want to find out the resistance, the definition of resistance is that it is a ratio of voltage and current. So if you want to find out the resistance at any specific point, you read the voltage at that point, you read the current at that point, and you will be able to calculate the resistance. Because a similar formula is something that we use to define resistance. If I'll ask you a question, which is, what feature of the graph represents resistance? It's not the gradient of tangent, but it's the gradient of a line from origin to that specific point. So if you draw a line and you would determine its gradient, that would represent the resistance. Resistance is the gradient of that particular line. So the question was, what feature of the graph represents resistance? So you'd say gradient of line from origin to the point. Look at it again. If I draw a line from origin to this point, wouldn't the gradient of this line be just simply V upon I, because the other point is 0, 0? But yeah, I mean, for VI graph, it's the gradient, but for IV graph, it's 1 upon the gradient. Because if you find the gradient of this line, you won't get V over I, you'd get I over V, but resistance is V over I. So you need to reciprocate it. You need to flip it over. So you have to remember that for VI graph, resistance is the grade of the line from origin to the point. For IV graph, it's 1 over grade of the line from origin to that point. This also justifies the fact that why with a metal filament, it bends towards the V axis, because as the graph is bending towards the V axis, the gradient of the line from origin to the point is increasing. So resistance is increasing. So whenever there is an increasing resistance, it bends towards the V axis. And whenever it's a decreasing resistance, like in case of a thermistor, thermistor is a semiconductor, it's a metal oxide whose resistance decreases with increasing temperature. So instead of bending towards the V axis, it needs to bend towards the I axis to show a decrease in resistance. And for a fact, you also need to know, I mean, in A2, you will learn why the resistance of thermistor decreases with increasing temperature. That's not your part of AS syllabus. But for part of AS syllabus, you need to know that for a metal filament, like a heater or maybe a filament of a bulb, why resistance increases with temperature. So you need to be knowing that as temperature increases, the molecules start vibrating faster, and that will offer more hindrance towards the flow of electrons. Electrons find it harder to pass through molecules which are vibrating with greater amplitudes. So at higher temperature, the molecules of the metal are going to be vibrating faster, and they would bump more vigorously into the electrons, and hence offer more resistance towards the flow of electrons.